So here's another transform that we would like to find the original function. In other words, the inverse transform. But notice that this one doesn't look like any of the basic forms that you've already learned. So remember, the denominator is the focus of the transform. So we have to make that denominator look like something that we've dealt with before and realize that this particular one can be factored, which means an old friend is going to come for a visit, that old friend being partial fraction decomposition. So the key is to rewrite this as some constant over one factor plus some constant over the other. And at this point, we can actually say that f of t is equal to ae to the 3t plus be to the negative 2t, just comparing to the transforms. We know the transform of each individual term here, or we know the inverse transform, I should say, of each individual term there. So now the goal is just to figure out what a and b are. Well, remember, this is just basically from calculus. We multiply both sides by the LCD. So we have s equals a times s plus 2 plus b times s minus 3. And this one we can get away with just substituting values of s in order to figure out a and b. So I'm going to plug in s equals negative 2, and that's going to give me negative 2 equals. The a term is going to go away because that's multiplied by 0, and we have b times negative 5, which makes it look like b is equal to 2/5. And then if s equals 3, that's going to make the other term drop out. So we have 3 equals a times 5, which means that a is equal to 3/5. So that means that my original function, or I should say my inverse transform, is 3/5 e to the 3t plus 2/5 e to the negative 2t. And there we have it. So if your denominator factors, partial fraction decomposition could get you to a transform that you know, that a familiar transform form. Transform form? That's weird. Anyway, thanks for watching.